This is an example from textbook. You can pause this video and read the question. You need to notice the different sample size. So we know it cannot be dependent samples and has to be independent samples. There was no mention to matching the man and a woman on any characteristic, so those samples are independent samples. We are interested in this question. Is there evidence that there is a difference in the mean ideal number of children for a family to have between woman and man? Use a level of significance of 0.05. So group 1 represents woman, group 2 represents man, and the null hypothesis will be mu1 minus mu2 equals 0, or equivalently mu1 equal mu2. The alternative hypothesis will be mu1 minus mu2 doesn't equal 0, or equivalently mu1 doesn't equal mu2. I will show you how to reproduce this result here. So we have the sample mean, sample size, and the sample standard deviation. To reproduce the result in page 42, we need to click on Stats, T-Stats, to sample T-Test, and we want to click the option with Summary. For group 1, the sample mean will be 2.54. The standard deviation will be 0.89. Sample size is 921. And for group 2, the sample mean is 2.5. Sample standard deviation is 0.85. And the sample size will be 754. Do not click the poor variance because we want to use on-port variance. And we click Compute. As you notice, the result here is identical to what we have seen in page 42. Because p-value equal 0.3484, it is larger than usual significance level, so we do not reject the null hypothesis. So we can answer this question. Is there evidence that there is a difference in the mean ideal number of children for a family to have between woman and man? So you can answer it professionally as with p-value equals to 0.3484, there is insufficient evidence that there is a difference in the mean ideal number of children for a family to have between woman and man. We can also use StatQuant to calculate the confidence interval. So in the window we just created, we just click on Edit. This is the result for the hypothesis testing. So we can click Edit and change the option from hypothesis testing to confidence interval. And we want the level of confidence to be 95%. And we'll click on Compute. As you may have noticed, this result in this window is identical to what we have seen in page 44. So we are 95% confident that it is unclear whether woman or man has the greater population mean ideal number of children. Because the interval contains 0, there is no evidence that there is a difference between the two different groups' average number of ideal children. Here is another example. You can pause this video and read the question, including the summary statistics and the box plot. From the summary statistic here, we can see the sample mean of group 1 and group 2 are actually close to each other. So without doing the hypothesis testing, my wild guess will be there is no difference between these two groups about the population mean. The null hypothesis will still be mu1 equal mu2, and the alternative hypothesis will still be mu1 doesn't equal mu2, with the p-value equals to this number, 0.7989. It is larger than any usual level of significance. So we do not reject the null hypothesis. Again, because the sample size of group 1 or group 2 are not equal, we are confident that we have independent samples. Now we can answer this question. Is there evidence at the 0.05 level of significance that there is a difference in the mean selling price of the two methods? With p-value equals to 0.7989, there is insufficient evidence that there is a difference in the mean selling price of the two methods. We will get the same conclusion if we generate the confidence interval using StatCrunch. We are 95% confident that it is unclear which method, buy-in or buy-it now, has the higher population mean selling price. Note the interval contains 0, which means the two means could be that is, it is possible there is no difference between the average because 0 is in the interval.